In this video, I'm going to explain the implementation of lessons 2 of the Raspberry Pi on this University of Cambridge website. Lesson 2 builds on lesson 1 as explained on the website. I'm not really gonna go in details into explaining the code, but I'm simply gonna I'll show the implementation of the code, and then after I'll run the code, and then after I'll demonstrate how the code were able to execute on the Raspberry Pi. Um, the code already is given already, so there isn't really much coding we are going to do. So without wasting time, I'm gonna go to my tool chains where I have my lesson 1. So my tool chains, which is saved to the local drive, and this my arm tool chain, so which is I'm gonna go ahead and open that, and my main file, it's in the bins folder, so I'm gonna go ahead, double click that, go to the source, and here I have my main file. So I'm just gonna go ahead, open my main file, and then edit, like add on the code which were given on the website. I'm just gonna go edit. As you can see, these are the code for exercise 1. So we're just gonna do a small tweaking here and there. So we're just gonna change a couple stuff and then generate the new Canon image and then run it on the Raspberry Pi, and that should be able to run to make the lights blink on and off for some time. So really all I will do, I'm just gonna go back to the website, and then I'm simply gonna copy the code. I go back, and where I have this already, so which is the same thing, so I'm gonna copy the one I have here. uh, so after copying the code, really all I'm gonna do is just to be paste. So this the new code that I have, and as you can see, but however this is not yet done, so there is some modifications that we need to do. And we know that these instructions, the the offset of 40 turns the LED, the offset of 30 from the GPIO turn the LED on. So really what we want to do, we want to be able to modify this, and already as explained on the website, we know that by writing the offset of 28 from the GPIO controller instead of the 40, that will be able to turn the LED off. So really basically that we're gonna do, we're just gonna change the 40 to 28, and then causing the LED to turn, off. And after modifying this, and then we're just gonna go ahead and then add on a couple more codes which will be able to really do the trick. And I'm gonna move R2, zero, Mm. And so this really all we need. And after writing this, we're just gonna go ahead and save it. So we're gonna go ahead and save the file. So after saving the file, we're gonna close it. And really the next things that we wanna do is compile now the program. So we're just gonna open the command prompt. After opening the command prompt, then we're just gonna go see. We wanna clean the folder because the folder of previous files. So really what we wanna do right now is now clean the previous folder. So by then we're just gonna go pmake whatever you named it. So mine I named it pmake, so you can name it pymake or whatever you named it. So we're gonna go pmake clean. Go in. Well, as you can see that this was unable to execute to really clean up the kernel's image. So, and this really been happening in Windows 8. I don't know really what's the matter, but since this is not being able to clean up, so we just can do this manually. So now to do that manually, we're just gonna go open. Starting from the beginning, open our bins, go back to the bins folder, opens that, and then delete the builds files. So we're gonna go ahead and delete the builds file, delete the builds files, go at the bottom, and then delete the kernel image because this image is the older file, so we don't need it. We wanna generate a new image, so we're gonna go ahead and delete this. So go ahead and delete that. We also don't need that, so we're gonna delete that as well. And we're also gonna delete the map files. We're gonna go ahead and delete that. And just a reminder, that's where my pmake is. And then we can close this, and then we can return back to the, and then just pmake. Yes, so that was successful. So we can see that now we were able to create a new, this the new Canon's image was built. I mean the map, and this were the new image, and this were the new Canon list that were built. So after building this, now really the last things we want to do is just to copy the new created image and copy it to the SD card. So now if we open our folder and going back to our C drive, our to the tools bins and the bins, we can see that here is the new source files have been created. And if we go at the bottom, we also can see that the new kernel's image has been created, and the new kernel list have been created, and new kernel map have been created. So really now what we can do now is to simply copy this, copy the new kernel's image, and then after that transfer that to your SD card. So we're gonna go ahead, copy the image, and then the next things really we want to do is to go ahead and plug in our SD card in the computer. So I'm gonna go ahead and plug in my SD card. So as you can see, I just plugged in my SD card, and which is right here is E. So I'm gonna go and open that, and this has all the files that I have. So I'm gonna go ahead and delete that because I don't really need that. Go ahead and delete that too. Or I can simply rename it. And 11, and then after renaming that, then I can paste, as you can see, past my. So this is my new Canvas image, which will be able to blink on and off. This will be able to blink the Raspberry Pi. So after really doing this, now the last thing is really simple, is to simply take your SD card, put it on your Raspberry Pi, and boot your Raspberry Pi, and the LEDs should blink on and off. So really that concludes the end of the first part of this video, and in the second video I'm going to show how the lights on the Raspberry Pi was able to like blink on and off. We checked that, and also, and I'm also gonna